Hi, so in this video we are going to solve question 4.2.3, and this is this differential equation dp by dt is equal to p delta vap h over rt squared. This is a version of the Clausius Clapeyron equation which you'll see in thermodynamics. But in its differential form it's not terribly useful. We want to get it into a form where we can say what the link between the pressure and the temperature is and how ultimately that is used to determine the enthalpy of vaporization is what you will learn in your thermodynamics course. So as always with any of these differential equations, the first thing we need to do is separate it so that the like terms are together. So I'm going to integrate one side with respect to p from the dp, so I want to collect all of my p's on one side, and I'm going to integrate another side with respect to t, so that's the dt, and so I want to collect my t's with the other side. It doesn't particularly matter where my constants go, but I tend to leave them as alone as possible. So the first thing I'm going to do is just collect my terms. So rearranging this, sorry, let's change my colour pen. Rearranging this leaves me with 1 over p dp is equal to delta vap h over rt squared dt. And this is a bit of a fudge, and so you see me always putting speech marks around it because this isn't quite true as it stands mathematically, but it's a good middle step. So the next thing I need to do is integrate this, and I'm also going to apply my limits onto this integration as well. But you'll notice that when I do this, I have a tendency to separate out my constants from my integration. It just makes it look simpler for me. It's not necessary, but for me, it just makes it look simpler. Oops, wrong variable. So my pressure terms belong with my dp, and my temperature terms belong with my dt. Oopsie. And so now this is what my integral looks like. So I just need to take each of these two integrals in turn. So if I take the pressure one first, if I integrate 1 over p with respect to p, well, that is that special case where I end up with the natural log of p. And this is true between my limits p1 and p2. On my other side, well, what I'm going to do is I'm just going to make a quick aside here to basically say, well, 1 over t squared is equal to t to the minus 2. So when I'm integrating this, I'm going to think of this in terms of t to the minus 2. And so I am going to follow my rule for polynomials. Add 1 to the power, divide by the new power. So this is my constants. I'm just going to leave those as they are. And then I'm going to integrate 1 over t squared with respect to t, or t to the minus 2 with respect to t. So add 1 to the power becomes t to the minus 1 divided by the new power. So that's minus 1 over t between t1 and t2. So now I've got this integrated and I have my limits. I have my top power substituted in minus my bottom power substituted in. So here on the log side, this is going to be log p2 minus log p1. And then on the other side, this becomes minus 1 over t2 minus 1 over t1. And I've written it like that to be really clear, and I'm just going to tidy it up in the next step. So if I tidy this up here, I'm going to tidy up my logs first because I can collect them in my rules of logs. Remember that the log of a minus the log of b is the log of a over b. And then this can be written as, because my 1 over t1 is positive, I can write it like this. And this, as far as I'm concerned, is a finished answer. But I am just going to make a couple of notes here very, very quickly to say that sometimes you might see this equation in slightly different forms. So, for example, when I use it in thermodynamics, I have a tendency to write it slightly differently, which is minus delta Vap H over R. And I've done that by just flipping this term in the bracket. So instead of it being T1 minus T2, it's now T2 minus T1, and that accounts for that extra kind of minus sign that we've introduced outside. So just as a warning, there are different ways that this can appear. You can also flip the log P1 and P2, doesn't really matter. But what I'd say is that you just need to be consistent. As long as your P2 and T2 go together, P1 and T1 go together, it doesn't matter which way that you've got on the top or the bottom, it will all work its way out. Just take care, integrate each one in turn, separate your variables, make additional notes if you need to. Hope this helps. Bye bye.